Alright guys, so you have learned so much. You've learned all of the hard stuff. The next few concepts that I'm going to teach you are either shortcuts or just, variances of ways to show electron configuration. None of which are as long as full electron configuration or orbital diagrams. So noble gas configuration is a great shortcut for writing the full electron configuration. I do want to point out, though, that you can't make this your default form of writing electron configuration. We will ask for it. Okay, so always pay attention to what you're being asked to write on your assignments or assessments. Okay, so for electron configuration, the full electron configuration, let's do something just brutal. Let's do strontium. Okay, so we're going to start all the way up here at hydrogen. Oh no, I didn't mean to write on that. All the way at hydrogen. Energy level 1, sublevel S, 2 electrons there. We are doing, guys, strontium. So you can kind of just mindlessly write your electron configurations if you are good enough at that, and until you get to energy level 5, that's when you need to really focus and make sure you're paying very close attention. So I'm just going to go through the full electron configuration until energy level 5. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. This is where I dip down into 3d, 3d10, back up to 4p6, and now I'm on energy level 5. Okay, strontium is in the S sublevel of energy level 5, and he is 2 blocks in. So 5s2 is strontium. Okay, now this is a lot. Okay, so you can take the electron configuration that represents the noble gas right above him. You can't use xenon. Okay, it has to be the noble gas on the period above him. So krypton. Krypton's electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. Okay, so you can take that electron configuration and instead of writing it all, write the noble gas. And then just write the valence energy level. The valence shell electrons. Okay, that was for strontium. Okay, so let's do another one that is tempting to use a different noble gas. Let's do iodine. I'm going to be really mean again. Okay, so iodine is way down here on energy level 5, all the way over in the P block. Okay, so we're going mindless here for iodine for 4 full energy levels. Iodine. I can't spell. 1s2, 2s2, 2p6, 3s2, 4s2. Gotta dip down into 3d. Don't forget that. If you can't remember that yet, you cannot be mindlessly writing these yet. You need to still be going with your periodic table. Okay, but if you can remember that, then you have permission to just quickly move through the electron configuration. Now I'm on energy level 5, which is where I checked iodine was. Okay, so 5s2, still not there. 4d10, still not there. Back up to 5p. 1, 2, 3, 4, 5 boxes in. 5p5. Now, the closest noble gas is xenon. But you cannot summarize the entire periodic table up to iodine with xenon. Okay, it goes too far. So you have to start with krypton. It's the noble gas on the period or energy level above him. Okay, so we've still got the same noble gas that we're using as our shortcut. Okay, so when you put krypton in brackets like that, it represents 1s2 all the way to 4p6. and then you're just writing your valence shell. Or not your valence shell, I should say your highest energy level. 4s2, 4010, 5p5. Okay, this is the noble gas configuration for iodine. Let's quickly just make sure we're good with the number of valence electrons in iodine. So I'm looking for my highest energy level, which is 5. 4 is not. Okay, that's in the 4th energy level. There's another 5. So I'm dealing with 2 electrons from my S sublevel and 5 from my P. So that means iodine has 7 valence electrons. And if you check, he's in group 7A. That's your halogens. They all have only 1 valence electron to go until they become a noble gas. Okay, they really, really want to gain that 1 extra electron. So, it's been a while since I have done an orbital diagram with you guys, so I just want to recap that. And I'm not going to do strontium or iodine. Okay, that's really a lot for you to sit through and watch. So I'm going to do gallium. Okay, he's over here. He's on the 4th energy level, so we'll do one with a D block. But he's on 4p1. So this is just extra. I'm no longer doing a noble gas configuration. It's just been a while since I have gone through an orbital diagram for you. So we're kind of just going from one end to the other. One end I'm giving you a shortcut, and at the end I'm making you sit through an orbital diagram. So I wanted to do gallium, who's Ga. I can just kind of mindlessly go through my electron configuration until I get to whatever energy level he is on, 4. Okay? When you're doing orbital diagrams, though, you need to leave yourself space for each orbital. Okay, so 1s2, 2s2, 2p6, 3s2, 3p6, and again, you can split those up if that's getting too run together, okay? 4s2, we are on gallium's energy level, so I'm going to slow down and make sure I'm doing this right. 4s2, 3d10, and D has 5 orbitals, okay? And then finally back on 4p, and he's my first block in 4p, so 4p1. Okay, orbital diagrams, remember our 3 rules. Aufbau says we fill our first energy levels, our lowest energy levels, and our lower sublevels before moving on. Hund's rule says 1 at a time, and Pauli exclusion says they have to rotate in opposite directions. Okay, so now I just get to go in and fill in my arrows. Aufbau says I can do all of 1s2 before moving to 2s2. Pauli exclusion says they are going in opposite spins. And Hund's rule says when I get to 2p6, I'll go 1 at a time before pairing them up. (3d10), 1 at a time before pairing them up. Okay, now 4p1, I only have 1 electron. Okay, remember, we mentioned 1 unpaired electron. He doesn't have a partner, and there's no other electrons in there. So I don't know if you remember from several videos ago, if I can find my notes that I did. So chlorine had 1 unpaired electron, and he had 5 electrons in that p orbital. Gallium also has 1 unpaired electron, so just kind of to pay attention to that. There can be different reasons for being an unpaired electron. So lastly, to kind of tie it all together with everything you've learned, if you were asked how many valence electrons you have some on energy level 4 in the S sublevel and some on energy level 4 in your P sublevel. 1, 2, 3. 3 valence electrons. D doesn't count because he's on energy level 3. Gallium is in group 13, or 3A. Okay, voila.